on the MGI platform our team has been established. So maybe this self-introduction by myself. So I'm Fang Chen. So you can call me Alice. I'm the director of the Application Center of MGI. So application transfer include the reagent, library reagent, the software, the algorithm team. So we have different teams to pick the products from the market requirements. And also, I have a position in the WGS research, so I do some research on the children and the maternal health related like disease and also the healthcare system. So first one, I will show you that the MGI products for the library part will be divided two brands. First one we call MGI Easy. So the MGI Easy system kit is designed for research use at the moment, only for research use. So for all these kits, we will not apply for like the CIVD or CFD approval for MGI Easy. We just for the scientists or for the researchers to use. And for the clinical, we need the MGI care system kit. So if you look at our reagent kit, there will be two different systems. So we have the MGI care library kit, and we will select some of the kits to package with the software and the sequencer and to apply for CE marker and also for the CFDA approval. So like the reproductive health, we have the PTS for the single cell sequencing. Tomorrow we will have a complete introduction of the PTS products, which include the kit here. And also we have the objective detection for chromosome copy narrations, which provide for the newborn disease screening and also for the miscarriage tissues. And also for the NRPT, so include the kits here. We have developed some cancer panel kits here, and also we are open to integrate the third-party commercial kits here, like the Paragon and also like MyPT, some other kind of panels kit here. And for the pathogen identification, we have very close relationship with the CDC system in China, so we developed the plasma-based and also the liquid-based library kit for them for the pathogen identification and also including some softwares. So for the MGI library preparation system, actually we are quite open to all these institutes and collaborators. The first part, we will develop some library kits and system and softwares to prove that our sequencer is trustworthy and confident to all to receive all this kind of tests for research use and for clinical use. And also we are co-develop the products like we actually were working with some reagent companies to develop some products which is not valid in the current product catalog. And also we have some open system to help our customer to use the library kits and also for other sequencing platform and also for the other probe which can combine with our library kits. The one example is a home exome sequencing. So the library kits can be integrated to other probes, exome probes from like WGS company. So we are open to 3 different modules, and for some co-development products, we still have some possibility to do co-marketing. So whole genome sequencing. So for the whole genome sequencing, we have the previous design. So we want to see what's the trends of the whole genome sequencing. So it's easier to see the trends for human. So at the moment now, the whole genome sequencing is used to get blood samples, tissue samples, to get microgram DNA from these human tissues, and you sequence it. You got deployed genome from the sequencing data. But actually, the trend will be two parts. The first one is the DNA input will decrease from microgram to picogram. So we can see there's some application they are using the picogram and they're using the nanogram. So the DNA input, which use more than like 3 or 5 microgram DNA input, is will be more and more less to ease to see. And also there are some kits which help the customer to get the haplotype genome information from the home genome sequencing data. You can see at the moment the peptide sequencing and also ONT they call it the third generation sequencing. They mostly focus on the haplotype genome information. And also from the tissues, you got thousands of cells, thousands of like live cells, dead cells from the biological samples, and then we can sequence with the less and less biochemical samples. And finally, we can reduce to the single cell. So at the moment now, the single cell genome, whole genome sequencing has been used for like the embryo sequencing and also the tumor sequencing. Because I think 5 or 6 years ago, the single cell sequencing from the tumor is really popular and published lots of papers on very high impact factors. So for the whole genome sequencing, we'll develop according to this different scope. So we will have different design for this library kit. And also, along with the library kit, we have to develop the compatible sequencing strategy and also the bioinformatics software. For some application, even we have to build, or our customer collaborator can build the database for clinical integration. So this is for whole genome sequencing. There are some criteria to evaluate how this library kit and this product is good or not. You can see the data input and the sample types, whether it's only limited to human or to animal, plants, microbes, any kind of other species. And there's one, so the variants in the genome, which kind of variants included in your sequencing data. So usually we only look at the SNPs and the indel. So if you look at all the product introduction, how the SNP accuracy, the indel accuracy, but you didn't see not too many about the copy narration, CMV and SP. And even there's some very complex, like rare disease, low frequencies mutations in the genome. You can need not see many information, and also not in the haplotype. So there are lots of we call like markers or variants you got from information you got from the whole genome sequencing. And also the total solution. We know the total solution includes the library, actually sometimes including the DNA extraction, but depends on what kind of customers. So the total solution usually will include DNA extraction, library preparation, sequencing, bioinformatic analysis, actually sometimes including the database filter and also the clinical integration. So, and also for the estimation. So actually, because maybe 5 years ago, 10 years ago, the whole genome sequencing full automation is not so popular because the sequencing cost is really high. There was not so much lead to perform the automation system for the library preparation for whole genome sequencing. But now, because the sequencing cost has dramatically decreased dramatically, and also the throughput increased. Like the T7, Jing has introduced, can produce 60 whole genome sequencing a day. So the automation system for the library become more and more important for all our customers, not just including the hospitals and also including the researchers in the institute. And for the expansion for this very specific applications. So everyone knows that actually NLPT, the first application which helped to expand the use of next generation sequencing. So before 2008, nobody knows next generation sequencing because there was not a famous or well-known application in the clinical setting. But I think NLPT has introduced a window or produced an opportunity for all these users to get to know about the sequencing technology. So for these 5 different criteria, we will set up different goals for our customers. So we have 5 different library kits on sale, 2 with PCR, 2 without PCR, and another with single bar is a unique technology we can introduce a little bit later. And also, along with this kind of library kits, we have some expansion of the specific applications. We have the library kit for NLPT. So if your customer is an NLPT provider or lab in the hospitals, they can use it. And we have the single cell CLV test is for PGS, and we have the chromosome CLV test for the newborn test and also the miscarriage issues. So there are some specific applications. Here I give you a whole scope. Maybe we will later look at it one by one. So you will see the 2 library kits with the PCR cycle, the PCR cycle actually 7 cycle. So you can see the most of the with PCR library kit we are compatible with most of the species you can observe or use in the lab. And also it can be compatible with carbons fragmentation and also with enzyme fragmentation. So different kits they will target. Even actually we know that for the current library home genome sequencing kit, they can give some information for common CLV and SVs, but mostly they will look at the individual SNPs. Anyway, you can find some algorithm to analyze the CLV and SVs. So, and also for the PCR-free, we still also have 2 different ways. For the first one is fragmenting it after carbon fragmentation, and also we have an enzyme-based PCR-free kit for the genomic unit. So we have a unique library kit we call single SDFR for short. Is for the very long fragment DNA. So you can see the fragments. We ask for the DNA longer than 40 kilobase. So if it is too short, they will not recommend you this kit. Because for this kit, you can get the normal assembly for the species, including animal, human, and plants, and you can get the haplotype information from here. So the rest 3 kits, they can only be used to package with some kind of specific applications. They cannot be used independently at the moment. So the first one is the MGI Universal DNA Library Kit. Why it's called universal? Because it's the first kit we developed for all these species. So we compared the human, animals, plants, microbes, or even single bacteria, variants, and metagenomics. So we tested all these kind of samples types. It works all the time. And this is just one data to show you that for human, we use the reference standard samples to see. After we started for 500 nanogram DNA, we fragmented by carbons, and we got almost 8 to 10% of the DNA after base purification. So you can see we have very similar coverage compared to the domestic, and we have actually on alignment we have much lower duplication rate. So we have some applications and the feedback from our customers. It's talking about the duplication rate. Actually, our sequencing platform is much better than the domestic. And also for the variant evaluation, I think because in the morning Jim can talk a little about the DNB stick, because I think from all the data we got from the customers, I think in their calling variants, in their variants calling accuracy is much higher than the domestic and even the high stick 2500. And you can see the rapidity between our MGI sequencing platform, from this kit and the from Luna sequencer, the overlapping portion for the stick, and also the Intel actually is quite good, but Intel is lower because the Intel information we got from the Illuminant is much less than the based on the our sequencer platform. And this is for FFPE. We know that for tumor FFPE samples, not is quite different from the blood or tissues. It's very sometimes the quality is very bad. So we didn't require for the normal 500 number. Usually we'll recommend our customers to use half of the DNA input for the lab preparation because they cannot get enough DNA for lab preparation. And also we ask them to increase 1 to 2 cycles during the PCR step. And also you can see that we have example show here to see different DNA inputs and different quality. So the Q value here actually is the quality control step in MGI. We developed with the compound kit. It's like the real-time PCR kit to see the quality of the FFP DNA extracted from the kit. So you can see with you can see there are different quality here. Usually, we want to order this two values be more than 0.4. So 0.4 samples will refer to the A class DNA quality for FFPE samples. So I guess some of you have already seen some FFPE samples. We have different quality standards for grades for the DNA quality. So if the DNA is really mass, highly degraded, so if the data will not be good. So you see sometimes it cannot because of biological samples. And also you can see from this from the data from 2000 to X10, we have the similar, I think it's similar mapping rate and the coverage, and still the same conclusion. We have lower duplication rate, and I think this match rate is little lower. Yeah. So okay, I forgot to mention that for each time for the FFPE samples, if you produce one DNA library is enough for you to sequence 3 times. So this is for animal samples. This is for mouse. This is from mouse genome. You can see from the show some criteria here. The memory rate, the duplication rate. I think duplication rate is higher, 5%. Your needle should be lower. And this match rate is almost 1%. Chemical rate is not high, so that's quite low. So there's some GC bias studies to show you that actually the observed GC distribution is quite similar to the theoretical GC constant, also this accumulated coverage from the home genome. And this is for plant sample performance. This is for rice. So actually we have seen a lot of rice samples. in MGI. So the same, we started from 500 nanogram genomic DNA, and we got 10% of the distinct fragmentation and base duplication. And this is some of the criteria to show you that. And interesting, actually, for this time, the chemical rate is a little higher. Sometimes we observe some of the chemical rates is a little higher than pumps. I'm not sure whether it's because it's a multi-ploid genome. And this is for bacterial samples. Why we have to show here independently? Because actually, the bacterial samples, they have very unique GC content. So for each different bacteria, if you start with the same DNA input, sometimes you cannot get the same performance from the sequencing platform. So you can see we choose 3 different bacteria to show you that for each kind of very high GC content bacteria and very low GC content, actually it's not very low. We have lower some other bacteria, but still you can see the we have I think the GC bias performance actually is similar to the whole GC scan of the bacterial genome. And actually, I have to highlight here. So this kit actually can be used to less DNA for bacteria, only for bacteria. Why? Because the bacterial genome is really small. So even you have like this part, 5 nanogram, if you started with 5 nanogram or 0.5 nanogram, you still have enough copies of the bacteria for your library preparation or for your data aggregation. But 5 nanogram or 0.5 nanogram is totally not recommended for humans because it will introduce a lot of bias or errors during the PCR because you have so high PCR cycles. But for the bacteria, it's okay because all of the DNA came from the same bacteria, so it's easier for you to see the it's easier products or it's cultured bacteria DNA. And this is for meta. So the meta DNA is different from the bacteria, single bacterial variants, because the meta, there was a lot of bacterial variants fusion in it. So it looks like the genomic DNA. So the protocol for the meta DNA is similar to genomic DNA. You still have to do the very precisely fragmentation, precise selection, and also for the sequencing. So here we have 3 different samples. Actually, I think it's the repeats. It's 3 different. It's 3 1 sample, 3 repeats. So this is from the gene consistence. So for this part, you only see how many bacteria or how many kinds of bacteria in this sample. And this is for assembly. So after aggregation-based assembly, you can see how many species can identify in the samples. So actually for the meta de novo assembly for the use of genome sequencing is now quite popular in China. Maybe in some publications they have already to release some kind of algorithm to help the researchers to do the de novo assembly with the optimal sequence. Why they can do? Because most of the bacterial variants, the genome is quite small, so they still have some way to do the assembly. And so the above is the universal kit. So we call the FSDNA library kit. The difference is we use enzyme fragmentation instead of colors fragmentation. So this is the most different parts. So you can see because if you use the enzyme for fragmentation, you can do automation, you can do with a lot of high throughput. It's easier to use for all these packages. So still we have, I think we have similar coverage, even for this part obviously is lower, but I think it's almost the same. And for duplication, this is quite obvious for this kit. So you can see we have a very obviously very lower duplication rates here. And for the variant evaluation, actually for the indel precision and indel sensitivity, our sequencer actually, I think, will all the time perform better for the Nova sequence. And you can see we have a very high similar, we have overlapping function, we have very high accordance between the platform and also the and also for our sequencing platform. And for the FFP samples, the same. So the FFP samples, usually we have the quality here. So we hope the quality to be not so bad for evaluation. And also you can see from the mapping rate and the curve rate, we have similar the FFP samples for this test. And for the alignment, you can see from the duplication rate here. So actually, I didn't highlight it because these three different samples, they have different DNA input. So with have different DNA input. No, we have same. So we have the same DNA input but different quality. So here you can see the DNA sample from FNPE. The quality is better, and then the duplication rate is lower. Chemical rate, transparent rate is much lower, and also you can see the coverage and 20x is much higher than the rest two different samples. So in the clinic or medical centers, still have to highlight a quality control of all the DNA samples from the FFPE. So sometimes if the FFPE sample quality is really low, the sequencing you have to sequence more than you recommend. And question for the exam 2 kits is for the home genome sequencing library kits with PCR. The question? Okay, let's skip the PCR. So I think the presentation in the morning and also in early afternoon, our colleagues have already chosen some information on the PCR. So it's very easy to understand why the current PCR step introduce some errors before your sequence. First one, if you have a false steps during the PCR, it will be enlarged in the subsequent step. And also, sometimes the PCR will introduce an extra base pair. So this extra base pair, in the future, you will see an indel in your inserts or deletion in your sequencing data. And also the GC content, because for all these species, the GC is not even. Some of the gene region, the GC content is really high, and some regions really low. So for human, even we know the average GC content is 41%, we still have some region with very high GC content. So usually for this like very high GC content, we will just abandon the sequencing data because it's not trustable. Our PCR-free library protocol, actually PCR-free is not new technology. It's quite, I think when I joined WGI 11 years ago. So actually 2008, there's some protocol developed for PCR-free. So 11 years ago, the DNA input for whole genome sequencing is 5 microgram, and for PCR-free is 10 microgram. At that time, we used 10 microgram in genomic DNA for the PCR-free library. So after 11 years, the PCR-free library technology has been changed a lot. Most of these changes, they find a better enzyme for the ligation, and they have to find better enzyme for fragmentation and also for like site selection. So actually now the recommended for the PCR-free library kit in MGI recommend in with 1 microgram, but actually we still use some samples we use 500 nanogram. Even for some meta samples we use less than 200. So here I just show you that I think the perfect home genome sequencing strategy is the library kit is PCR-free, and also the sequencing is PCR-free. So at the moment, the PCR-free library, from this workflow, you can see no big difference. Just remove the PCR sample. So without a PCR step, it's easier for you to perform the molecular techniques labs process in your lab. You don't have to separate labs like pre-PCR lab, post-PCR lab, or any very complicated lab arrangements, and easier to do with even with single tube lab students. And also the DNA technology, because we don't with this, we use linear RCA technology, so there is no amplification errors during the DNA making step, because all of these copies always came from the original DNA template. So there were not column error rate, so you will see our indel calling accuracy is much higher than the current the next generation is using platform. So in this part, so we have a concept in this region. So if you want a perfect home genome sequencing data, you need to get PCR library, free library, and also the safety library. And for this first PCR free kit, you still use the target's fragmentation. So you still need the DNA sharing to get a fragment DNA for the A-tailing adapter ligation. And actually, for this step, we do a lot of modification, but you can still do it in your lab. The first one is how to fragment DNA to very small size distribution, because you want all your DNA as intense as possible. So you want a very intense size distribution. And also for the A-tailing adapter ligation, including the adapter ligation, you want to get a very high efficiency of the ligation between the DNA and also the adapter. Then you can get a very good high quality and high density of the DNA. Then it's enough for you to do the single-strand DNA making. And for this PCR-free library kit, so we start from 101 microgram genomic DNA, and the recommended with size actually is really tight. For the parent 100, parent 150, it fits most of these samples. So still find some very difficult samples, which very degraded samples we're trying. And there are not GC bias. We have better coverage even with high GC content or low GC content, and we have lower both positive and both negative. So because there was no PCR, so the whole workflow will be save a lot of time. So if you have a PCR, you have to prepare and mix the reagents, prepare the PCR, prepare the post-PCR base purification, so still save your time. And there's the duplication rate is much lower. But actually, for the current whole genome sequencing data, the duplication rate is really low now. It's less than 5%. So, but if you have some very specific application, so for example, if you want 100 depths whole genome sequencing for some specific application, then the duplication will be very important. And this is for the PCR-free library kit. So you can see here is multiple species, human, the representative DNA, mouse, rice, bacterial, meta, and you can see the this is for the representative DNA. You can see we have a very stable PCR yield after library preparation. Why we show this? Because if we don't have PCR step, most of us will be very worried about how many DNA we can get after we prepare before we sequencing. So here, just to show you that if we start from 1 microgram DNA for the PCR-free, so the DNA you get is almost enough for you to sequence 3 times, or even sometimes you can sequence for 4 times. So for most of the applications, it's quite enough. And also for the for 3 different GC content bacteria, so still have very flowed GC distributions, and this is a mock DNA, so we simulated, we can simulate some kinds of bacteria together with some fixed proportions. We see this is this original proportion we mix, and this is the PCR-free with the kit. This is 2 PCR-free kit. We see the proportion we got from the sequence data is very similar to the original one, and this is the PCR. So we still see there's some bias from the current PCR cycle, even for some very extreme GC. This is for the current. We use the carbons for fragmentation, and this is the another PCR-free. So we use the enzyme for DNA fragmentation. You will see the same. You can see different species, and also for the stability. So we compared with the okay. This is the above introduced about the PCR-free kit with carbons fragmentation. This is the PCR-free library kit with fragment DNA enzyme. So I think it's quite similar. And for the PCR-free, you can see the frequency of all these sequencing steps is actually much tighter, and also the PCR-free the depths for the dropout and for the high dropout, you can see very clearly, and also for the coverage for the PCR-free. I think most of them. Even for 20x is really high, but I think the PCR-free is much higher. So this one and this one is much higher than the current PCR-free. And one point, so even with PCR-free, we can get relatively lower. It's not obvious actually. So 1.2 and 1.9 is not obvious at all, but still, I just want to show you that because the current is the current standard of whole genome sequencing, 30x. So if you increase the sequencing depth, it will be very obvious for this criteria. And for the PCR-free DNA library, for the you can see the sensitivity for the SNP and indel. This is for indel. This is for SNP. Your SNP actually have very similar because it already reached the 99% accuracy. And also for the Intel, you can see the PCR-free, this plot. Yes, this is quite much higher. This is X10. This is I think 2000. There's some details to show you. This is standard then, single digit bar, as the standard home genome sequencing. And here I will just show you that for the PCR-free home genome sequencing. So actually, we sometimes will recommend our customer to use a low sequencing depth. It's sometimes is 10 to 50 x PCR-free home genome sequencing. So here, just to show you that the blue one is the current PCR-free with 50x, and the PCR with 30x. So you can see from the Intel and the SNP acting almost the same. The two lines merged together, and you see from the Intel the accuracy. I think the PCR free with lower sequence depth is better than the PCR. So in the future, if you try this case, you can see the data by itself. It's really interesting to see. We call it middle pass whole genome sequencing. So we have sent the report to the CKB to ask them to do validation in small samples for about 4 weeks. No, okay, good.